I should say happy Friday to you. It's Monday for me right now, but happy Friday to you. Hopefully I'm recovering nicely, and at the end of the video, hopefully I can say, I'll see you Monday, and I mean it. So, say a few prayers that I'm feeling good. I'll hopefully have an update for you. I'll send an update to some of the teachers to let you know how I'm doing. Okay, so again, we're going to solve radical equations today. What we're going to be looking at today, this is day 3. So you know from the past, day 3 typically means we've got some trick problems in there. It's going to still take everything you've done over the past 2 days, but now you need to be a little more cautious with what you're doing. So make sure that your notes are getting labeled, and we will get into the first example. Okay, example number 1. We've got the square root of d squared minus 11, and that's equal to 5. Now, this doesn't look very different from what you've done before, because you've got one side, you've got an isolated radical, the other side, you've got just a number. So you should at this point know that you've got to square both sides, because you've got to get that radical no more. You can't have a radical. So when you take the square root and you square it, all you have left is the radicand. So I've got d squared minus 11 equals, and then we're going to square this side and get 25. We need to solve for d, which means we've got to get rid of the 11, so we'll add 11 to both sides, and that's gone. So d squared equals 36. Now, yesterday and the day before, when we were solving, we would take and just get d equals 36, not d squared. So now you got to go back to what you remember about quadratics and solving those. To get d squared to be just d, you have to take now the square root of both sides, which seems kind of weird because we just undid that up here, but this is a totally separate problem, so we got to get d by itself, square root both sides. D equals, and now if you remember, lots of you had issues with this. When you take the square root of 36, you actually get 2 different answers, because there's 2 different numbers that multiply to give you 36. Both 6 and negative 6 multiply to give you 36. So we actually have 2 answers that we need to be looking at today. Typically, one of these is not going to work. That's not always the case, but when you get 2 solutions, you need to be really careful, because one of them might be, you remember the word from yesterday, extraneous solution. It's possible that both work, but that's not always going to be the case. So we're going to go over and do a check over here to see if these are solutions or extraneous solutions or what we've got. So I'm going to start by plugging in the positive value. We've got the square root of, we've got 6 squared minus 11, and I need to see if that's equal to 5. Exponents are going to come first, so I've got the square root of 36 minus 11 equals 5. Well, 36 minus 11 is 25, and the square root of 25 really is 5, which means that one works. Okay, so 6 really is a solution. It worked in the check, so we're not going to call that extraneous. We're going to call it a solution. Then we're going to check negative 6 as well. So I'm going to plug negative 6 into the variable up here. So I've got the square root of negative 6 squared minus 11 equals 5. And notice how I put negative 6 in parentheses. It's a negative, so I've got to put it in parentheses. That's going to be the case with all the numbers you work with today that are negatives, especially if you plan on using a calculator. So negative 6 times negative 6 is 36 minus 11 equals 5. 36 minus 11 becomes 25, and we actually get the same thing as we did when we checked the other one. Square root of 25 really is 5, so that works. So we did get both of these as answers, and both of them checked out. So we have answers of 6 and negative 6. If you remember, you could write this as plus or minus 6. So feel free to write your answer that way instead of writing them out separately, whichever one is okay with me. Okay, moving on. Next one. Square root of a over 2 minus 3, and make sure that you have the radical that goes over all of that, even the minus 3. And that's all equal to negative 32. The radical is isolated on the left-hand side, so we can begin by getting rid of it. We're going to square both sides. Over here, we just have what's underneath the radical. So we have a divided by 2 minus 3 equals. And then we got to square negative 32. If you're going to put this in the calculator, which you probably will, make sure that you put that in parentheses because it's the entire right-hand side that gets squared, not just the number portion of it. So it's negative 32 squared. Okay, I'm going to do that as well. You should get 1,024 when you take negative 32 and square. Okay, we got to isolate the variable, so we're going to start by adding 3. Get rid of that. We get a divided by 2 equals, that's 1,027. Woo, we're going to get some big numbers here. Solve this by multiplying by 2, and we get a equals 2,054 is our apparent solution, is what it's called. We haven't checked it yet, so we can't say it's our solution. It's our apparent solution. And we're going to check to make sure that this works. So I'm going to do the square root of, and I'm going to plug this in here for the a. I'm going to take that and divide it by 2 minus 3. I'm going to extend my radical there. And I need to see if this is equal to negative 32 or not. Okay, well, we'll start with the division. 2,054 divided by 2 is 1,027. Subtract 3. Subtract that and we get square root of 1,024 equals negative 32. And I'm going to grab my calculator and take the square root of 1,024, and it's 32. On my calculator it says 32. Okay, give me one second while I look something up, okay? 1 second. I'm back. I just wanted to make sure I was right about this first. So when you check, square root of 1,024 can technically be 32 or negative 32 when you take the square root. However, in the check, it's called the principal square root. Here, let me add in, I'm going to add in a new slide. And I'm going to have you do some vocabulary for me real quick. It is called the principal. Not like the principal of school, not principal, but principal. Principal square root. And what the principal square root is, it is real simple. It is the positive square root. So when you take the square root, really you have a positive or a negative, except when you're checking, you can only use the principal square root. So I'm going to make another, I'm going to say use when checking. With an exclamation point because that's important. Okay, so pause this if you need to finish writing this down. I'm going to go back to that last problem. So for this one, in the check, I ended up with the square, I used the principal square root because it's in the check, that's 32. But that's supposed to equal negative 32, that doesn't work. So I'm going to put a slash through here that does not equal, which means this apparent solution is an extraneous solution. It didn't actually work when I checked it because it didn't work in the principal square root. This is not an answer, which means I don't have an answer. So what you would write is no solution. I had nothing that checked out, which means I have no solutions at all. Okay, so be real careful with that check because it looked like I had an answer. I didn't. So be really careful that you're actually checking every single step as you go. Okay, let's look at another example. X equals square root of 2x plus 8. And it's the square root of 2x plus 8, the entire thing. So make sure the radical sign goes over the plus 8 as well. The radical is isolated on the right-hand side. So I'm going to begin by inversing that by squaring both sides. Unfortunately, what that does on the left is gives me a quadratic. I've got an x squared over there. On the right-hand side, I'm left with what's in the radicand, so that's 2x plus 8. I have to figure out how to solve this, but I have x squareds, I have x's, and I have constants. So I'm going to get this in what hopefully you remember is called standard form. Basically, everything is going to be on the same side as the x squared. The right-hand side needs to be 0. So I'm going to subtract 2x, and I'm going to subtract 8 from both sides. So that's going to give me x squared minus 2x minus 8. And that's equal to 0. So I just moved everything over to the x squared side. And this one, we're going to need to use factoring to solve this. This is what that whole unit, the last unit we were on, is all about. Hopefully you can remember how to factor. Factoring looks like this. The first two terms have to multiply to x squared. So in this case, it's got to be x and x. You could also use the quadratic formula if you really don't like factoring. But you got to remember how to quadratic formula. I'm not going to do that one with you. The second two terms, how that works is they have to multiply to give you negative 8, but they have to add to give you negative 2. So I know the numbers that multiply to 8 are 4 and 2. So I'm going to put those in here. I just need to figure out what kind of signs need to be on these to add together to a negative 2. Since it's negative, the bigger has to be negative, the smaller has to be positive. So these two numbers multiply to negative 8, but they add to negative 2. So that's the factored form. Then I've got something called the zero product property, which means I can take each of these separate factors and set them individually equal to 0 and solve. So I can take x minus 4 and set that equal to 0, and x plus 2 and set that equal to 0. First one gets solved by adding 4. So one of my apparent solutions, hopefully you're getting used to that vocabulary, one apparent solution is 4. The other apparent solution is, if I subtract 2, the other apparent solution is negative 2. Now don't circle anything as an answer. It could be that both of these work, it could be that neither of these work, it could be that one of these work. So I've got to go through the check to see which one is which or how that works. So let's start with plugging 4 back into the original equation. So 4 equals square root 2 times 4 plus 8. Multiplication comes first inside of the square root, so I get the square root of 8 plus 8. 4 equals the square root of 16. At that point, you should be able to say, yeah, that does work, because the principal square root of 16 is 4. So I'm going to go ahead and circle that one as an answer. So this is not going to be a no solution problem, because I just got one of them to be a solution. I do have to check the other one, because it could be that that one is extraneous. So I'm going to plug negative 2 in. So I'll just draw a line to separate that. I'm going to put negative 2 equals square root 2 times negative 2 plus 8. Negative 2 equals, do the multiplication first. 2 times negative 2 is negative 4 plus 8. I end up with negative 2 equals the square root of 4. Now, the square root of 4 is 2, except since we're in the check, we need to use the principal square root. And the principal square root of 4 is 2, not negative 2. So this one is considered to be an extraneous solution. How I want you to show that it didn't actually work is I just want you to cross it out. That's not going to be a part of your solution. The only solution is 4. Okay, I'm thinking we need another one of those probably. I can't see you, but I can hear your minds talking to me, saying that was too much, Shogren. So we're going to try another one. And this one is very similar. Let me get rid of that. That's there for some reason. So we have m equals square root of negative 6m plus 7. And again, that radical goes all the way over the plus 7 also. The radical is isolated on the right-hand side, so we're going to begin by getting rid of that, and we're going to square both sides. The left-hand side becomes a quadratic. So you can expect to use factoring to solve this because I've got an m squared. We're left with the radicand, so negative 6m plus 7 is what we're left with. Just like the last problem, we've got to get everything over to the m squared side. So I'm going to add 6m, and I'm going to subtract 7 over to the left-hand side. That leaves me with m squared plus 6m minus 7. And now that's all equal to 0. I have to factor to solve this, so we'll practice that one more time. The first two terms have to multiply to give you m squared. So I'm going to get an m and an m. That's the easy part. The second part is I need my numbers to multiply to negative 7, but add to 6. The only numbers that give you 7 are 1 and 7. So I can put those in. But now 1 has to be positive and 1 has to be negative in order to get multiply to give a negative. So which one should be negative, which one should be positive to add to 6? Since I want a positive 6, that 7 needs to be the positive. So I'm going to add this, subtract this. These two combined would give you 7 now. Or 6, sorry, would give you 6. So zero product property says take each of these two separate factors and set them equal to 0 separately. So I've got m minus 1 equals 0, and I've got m plus 7 equals 0. We've got two one-step equations to solve. This one you'll need to add 1. So one of my apparent solutions is 1. I don't know yet, don't circle that, because it might not work when I check it, but as of right now, that it looks like a solution. The other solution comes from this one, so I've got to subtract 7. And m equals negative 7 is my other apparent solution. Anytime you get a quadratic, an m squared or an x squared or something, you should end up with two solutions at the end to check. That's what a quadratic does. So let's start by checking the 1. I'm going to substitute in 1 equals square root negative 6 times 1 plus 7. So I get 1 equals negative 6 times 1 is negative 6 plus 7. Well, negative 6 plus 7 is 1. And the principal square root of 1 is 1. So the positive square root of 1 is 1. That means this one works. So I'm going to circle the first one as an answer. I have a check that proves that it works. Then I'm going to check negative 7 and we'll see what happens with that. I get negative, I'll just draw a line across here. I get negative 7 equals square root negative 6 times negative 7 plus 7. Okay, so we got to start simplifying in the radicand. The radicand multiplication comes first. So negative 6 times negative 7, make sure negative times negative is positive. So that's 42 plus 7. Negative 7 equals, this becomes the square root of 49. So the square root of 49 is negative 7, but the principal square root of 49 is 7. Remember, the principal square root is the positive square root, which means this is not the principal square root of 49. So that does not work. I'm going to cross that out as my answer. So even though it was an apparent solution, it's actually called, hopefully you remember, this is called an extraneous solution. So cross it out. You might want to write extraneous solution in your notes next to it so you remember what that's called. This is the only solution that actually works in the problem. Okay, let's see what else we've got here. Okay, let's go on to this one. We'll skip one of them here. Square root of d plus 7 equals 3 times the square root of 4d. So this is back to what we were doing yesterday, where now you have a square root on both sides. It's going to work a lot like yesterday, except we have a 3 in the front that we're going to have to worry about a little bit. So we're going to square this side, and we're going to square this side. We've got to get rid of those radicals. Over here it's easy. That's just d plus 7. But over here, you have to square both different parts of this. So the 3 is a number, that needs to be squared. 3 squared is 9. And then you also need to square the radical. So the square root of 4d squared is 4d. So you end up with 9 times 4d, which we're going to simplify down to 36d. And don't skip this step and think you're real smart. Okay, write this step, make sure you get the right result, the simplified result. This time we don't have a squared variable, we don't have a quadratic, this is linear, so it should be a lot easier to solve. I'm going to get the variables onto the same side. I'm going to subtract d from both sides, that leaves me with 7 equals 36 minus 1 would be 35d. And to solve for d, we're going to have to divide by 35 on both sides. And don't get confused, this is not 35 divided by 7. It's not 5. it is 7 divided by 35. So it's a fraction that needs to be simplified. Both 7 and 35 can be divided by 7. It's 1/5. You could also write that as 0.2 if you wanted to use the decimal instead, so it was easier to use your calculator perhaps. I'm going to leave it as 1/5. Oh boy. I circled it, but I don't know that's right yet. Hold on. Undo that. Okay. Hopefully you know why I'm doing this. That could be extraneous, so I don't know if it's a solution. I can't circle it in, not until I know that the check works. And actually, when I do the check, I think I am going to use 0.2 because it's going to get really messy. So let's go ahead and sub 0.2 in. We get 0.2 plus 7 equals 3 times the square root of 4 times 0.2. Left side is easy. 0.2 plus 7 is 7.2. On the right side, I get 3 times, and then we're going to do 4 times 0.2, so we get 0.8. You're going to need to use calculators from here on out because I can't tell if these two are equal yet because they're not all underneath the square root. So we're going to do the square root of 7.2, which is a real messy number. Just write down as many decimals as you think you can. So 2.6832. Let's say that should actually be a 3 because it would round up. There's an 8 next. Equals, and then I'm going to do 3 times square root of 0.8. And that is 2.6832, but then it's an 8, so it's going to round up as well. These are identical. They turned out to be the same exact thing. Since their decimals are the same, that means this isn't just an apparent solution, it's actually a solution. So I can circle 1/5 or 0.2 as my answer. Ta-da! Okay, so we're getting there. We're almost done. This is kind of a long video today. Sorry. We got a lot going on. I think we're going to skip this one. It would be a good idea for all of you to work on it and then maybe compare with each other what you got and see if you can figure it out all on your own. But time-wise, I'm not going to do this one, okay? We're going to go on to a word problem. It's going to be just like what we did yesterday. So, again, don't panic. Hopefully you can read that. There's kind of a glare, but it says, the distance d in feet that it takes an automobile to stop if it is traveling s miles per hour is given by, and then the equation they give you is s equals the square root of 21d. Find the distance it would take an automobile traveling 60 miles per hour to stop. And this is a true thing, by the way. This is not made up. This is real. So you need to know that you have a formula. So you're going to need to write that in your notes. S equals 21d. That's important. And you need to know that the automobile or the car is traveling 60 miles per hour. Our job is to figure out how long is it going to take that car to stop if they keep going 60 miles per hour and then slam on their brakes. So I'm going to copy